AI and .NET with Stephen Toub.
The Azure DevOps Podcast is a show for developers and DevOps professionals shipping software using Microsoft technologies. Each show brings you hard-hitting interviews with industry experts, innovating better methods, and sharing success stories. Listen on to learn how to increase quality, ship quickly, and operate well. And now your host, Jeffrey Palermo.
Welcome to the show. I'm Jeffrey Palermo, your host for helping you and your teams move fast and deliver quality and to run your software with confidence in Azure, all while using everything that the .NET ecosystem has to offer. The podcast is sponsored by ClearMeasure, a full-service software architecture and engineering firm serving companies that are shipping with .NET, building mission-critical software, rescuing failing and troubled projects, and always empowering software delivery with a proven approach. Quick announcement, I'm excited about my latest book being fully released just a few months back. It's about software leadership. It's called The 5 Pillars, Leadership for Effective Custom Software. And it's for anyone attempting to make a custom software team highly effective. And so if you want your team to deliver world-class results, the book could be for you. And teams are also using the book study guide for guiding retrospective meetings. And I'm excited about that. And if any listeners out there would like a free electronic copy of the book, just send me an email and I'd be happy to get it to you. And also, for those of you who are in a lead architect or software management role, you might be interested to join our monthly architect forum. It's a deeply technical session that I enjoy facilitating, a group of peer software architects. And you can sign up on clearmeasure.com. And we love doing that every month. And also you can subscribe to the YouTube channel, youtube.com/clearmeasure. All right. My guest today on the show is Stephen Toub. He is a partner software engineer at Microsoft. Stephen's been at Microsoft for nearly 24 years, and he's really done it all. And if it has to do with .NET, he's been in it. And today, he looks after all of the .NET libraries, making sure that .NET continues to be the fastest platform on the planet. Long ago, he ran the MSDN Magazine before it morphed into the docs and blogs of today. And he was a leader in the concurrency and async and parallel programming developments. And now he's turned his attention to pushing the AI envelope with .NET. So, Stephen, welcome to the show. How are you, sir?
I'm well. Thanks, Jeffrey. Thanks for the nice introduction.
Well, there's no way we could get through all of the things that you've been involved in. And I want to ask you about some of the current stuff, AI with .NET. But before we get into it, you've done a lot of speaking and you've taught so much, and there's a lot of listeners who kind of follow you and know who you are, but there's also a lot of developers who are probably seeing you for the first time. And so if you were to kind of back up, and there's no way we could cover all of your time in your career or at Microsoft, but were there any key points in the last couple decades that have kind of pushed you into what you're working on today? There's so many options for where your career could have gone. But how did it end up in this place?
Yeah, my career has been, I think, more varied than most developers that you'll find at Microsoft or at most large development companies. It took me a while to sort of figure out where my passions really were. And because I have multiple of them, and figuring out sort of the right way to combine them all led me through a variety of different paths. For a long time, I thought, well, I enjoy coding, but I'm not sure I want to be, a full-time developer where I'm locked in a dark room and people are slipping pizza under the door. I thought maybe I want to be a manager, and I thought, well, maybe I want to do writing more, or maybe I've had a bunch of different titles, PM, architect, technical advisor, developer, editor. I've been a manager, I've been not. And it probably took me half my career to figure out what I really wanted to do. And then once I found that, which is effectively my current role, I've been here since. And the role has morphed a bunch as well along the way, in some ways guided by what I'm interested in. But a few pivotal moments around 2007, our industry started talking about like, oh, not just multi-core, but many core. And there were all these efforts across a lot of the industry to figure out how do we take advantage of all of these processing units that were showing up. And, our phones have 8 cores, or my desktop has 8 cores or 64 cores, whatever. How do we best leverage that? And that led to a concerted effort within sort of .NET around what APIs and functionality do we add to enable developers to best take advantage of concurrency and parallelism. And I joined that effort pretty early, and that led to things like Task and async await, and that has sort of transformed not only the C# language and how developers write .NET code today, but also sort of my trajectory and my path. And then another probably pivotal moment for me was around 2013. We decided, we should probably start thinking about open source. We should probably start thinking about cross-platform. We should really have a .NET that is great for all platforms and that's fully open. And so that's what became .NET Core. And since then we've dropped the core moniker, and it's now just .NET 8, .NET 9, .NET 10, et cetera. But I joined that effort early on to sort of figure out and bootstrap what we were doing there, in particular around libraries. And then that led very early on to a push towards, let's not only make this OSS and cross-platform, but let's make it the fastest we can possibly make this thing and make it really competitive. And that also then sort of impacted my trajectory. And then probably most recently, 2 or so years ago, the AI became a really big thing. And I was sort of well positioned in the library space to focus on that and its impact on .NET. So if I had to call out a few moments, that's what they would be.
Yeah. Well, let's jump into AI. You've done a good amount of speaking, and any listeners, you can just do an internet search and you'll be able to find all those. But there's 2 tracks that there seems to be emerging, and I want to get your take on if that's the right way to think about it or not. There seems to be a lot of tracks, and you can get using Gen AI to build cool software, or to use large language models so that the software is really cool. And then there seems to be another track of just using Gen AI to develop the software. Are those 2 branches, or is there a third, or how do you think of it?
Yeah, I mean, one is about the developer themselves taking advantage of AI, and the other is about the software taking advantage of AI. And those are both important, and they're logically different. I mean, I spend a good chunk every day using tools that have been imbued with AI, whether that's actually in Visual Studio with GitHub Copilot and code completions and GitHub Chat, Copilot Chat and whatnot, or using ChatGPT, which I regularly do. I pay my $20 a month, and I have my personal ChatGPT subscription, and I use copilot.microsoft.com, and I use AI embedded in Outlook and Word and Excel and all these tools that make me as a developer and as a person more productive. I use AI in the evening. My kids ask me to write songs for them, and we'll use suno.com to create songs about unicorns and hamburgers or whatever. And
nice.
And we'll use ChatGPT or copilot.microsoft.com or to create images. So my kids has Minecraft characters or whatever, and it's both productive and fun. And so there's that whole aspect of it, just making developers better and faster and more efficient. And then there's the whole separate aspect of, well, how can software take advantage of it using AI effectively? I mean, there's multiple tracks here as well, but you can build, chatbots into your software, but you can also just take advantage of AI as effectively as a function that you call a unit of computation, right? Make a request, get an answer, and just use that as part of your software. And I think that's actually the future of where AI shows up in software more than chatbots. I mean, the interaction model with software of ask questions and get answers is great, but the ability to utilize AI as part of your application to compute things or to guide things or to orchestrate things, to act as agents on your behalf, is incredibly powerful. And I think we'll just see that grow more and more and more.
So it made me think, and let me ask you, the age of the generation of user interface where you had a form, and of course, then you had the form on your phone, you had phone apps, but you still have things to click, you still have text boxes to type things in, you still have drop downs. Is that UI paradigm going to be kind of swept aside, where instead it's just an English, more conversational interaction with the application? How do you think of that?
I have to believe so. I mean, there might be some visual aspects that continue to remain. That's still a useful tool. And with anything with AI, you always want a human in the loop. So there's always the human reviewing what the AI has done, and graphical representations of that are still very useful. So the AI populating a form that I can then scan to ensure it's correct before I submit it. Right.
Mm-hmm.
I hope that doesn't completely go away, but for a primary mode of interaction, you can already do an amazing amount of stuff just with voice. I mean, you look, I have, I'll use Copilot on my phone while I'm driving. The kind of the real time API based support that's on in a variety of apps now, but I use the Copilot app on my phone, and I'll do it while I'm driving and just having a conversation with the AI about some topic. And instead of listening to some science show, I'll just ask a question about some scientific thing that I know little about, and just ask more and more and more. And we have this dialogue. And with AI being imbued with tools, that can easily then be extended to not just information gathering and learning, but I'd like to submit an expense report. Go on to my OneDrive and grab the photos that I took of my receipts, and please create an expense report for me and tell me what you did. Okay, that sounds good. Go and send it off. And like that mode of interaction is very natural for people.
Yeah.
And I think it'll become the dominant mode of data entry moving forward. Data entry, data gathering. And
Right.
then when there's a human in the loop with those kinds of visual representations, it would be more about confirmation of what was done rather than typing everything in and clicking the boxes. And I think that will soon be a thing of the past.
Nice, nice. You also mentioned agents, and it makes me think of the expert systems, where there was a lot of marketing around AI in the 90s, and then it kind of tapered off and then came back. But in the 90s, which my career kind of started at the very end, so I was taught at Texas A&M University about expert systems. Neural networks was just this research kind of thing because we didn't have the compute power back then to even push it forward. But now expert systems, we just call them business apps, and there's rules engines, and people get work done. Is it the agents just maybe making more of the easy decisions, or is it a different thing? Is it an evolution of expert systems? How do you think about what the heck an agent is?
Everyone has a different definition. I think of it as just, we've had message-based systems since the 70s, right?
Mm-hmm.
Message passing-based systems.
Yeah.
And an agent is just an actor in those modes, right? It's something that you can interact with via making requests and getting responses. And those actors have always been able to talk to each other, right? They have a graph of these things and they can send messages to each other and so on. What's changed is that those actors are able to be backed by large language models, which are capable of very advanced reasoning. And so you imbue those actors with this reasoning-based model and sets of tools that are able to interact with the world around it. And now you've created, a person in a box, basically, that is able to do work on your behalf. You make requests, it does some processing, it calls out to various tools that are able to either perform operations or gather additional data. It's able to act on those and come up with its own plans for how it makes forward progress. and provide you back the results, provide you back requests for confirmation that it should be making forward progress. So an agent is really just this entity that you can interact with that has these capabilities built into it. And then there are, many different ways of expressing what these agents are. They can be very simple representations where you say, I want a HR representative agent, and I give it a description of who it is, which would be referred to as the system prompt.
Mm-hmm.
And I give it the model and the service that I want it to be using for its capabilities, the LLM. I want you talking to Anthropic and Claude, or I want you talking to OpenAI with GPT 4.5 or whatever. And you configure some aspects of how the model operates. These are parameters, words like temperature or top P or whatever. You basically configure how it thinks. And you give it a set of tools that it can interact with. Here is a tool where you can issue calculator requests. Here is a tool that lets you submit forms to the HR department. Or if this wasn't an HR rep, if this was a finance person, submit expense reports or approve expense reports or whatever. And you give it this set of capabilities, and then you're able to issue requests against it and have it perform actions on your behalf. And you then can create multiple of these. You can create teams of these agents that know about each other and are able to send messages between them and are able to collaborate. Again, in this actor-based message passing model that dates back 50 years, but with advancements in neural networks from the last 5 years.
I wonder, are there any debates that you're privy to? I personally I wrestle with this English term agent because it has such a human connotation. But when I think of this program that uses AI, when I think of it as a piece of automated business machinery, there's some really advanced automated machines on factory lines and CNC machines and 3D printers. And so I kind of wrestle with just the English language myself when thinking about that. And I'm wondering if there's any debates that are happening over that.
I mean, as is often the case in this day and age with how fast information flies around and how much people want to jump onto the latest cool bandwagon, agent is now a term that is being applied to anything and everything.
Mm-hmm.
And if it is anything that you can interact with in any way, shape, or form, it's getting branded as agent, right?
Yeah.
And so from that perspective, you just have to kind of take a step back and a sense of humor and say, like, okay, we're just using this term now to mean these things that can do processing and that you interact with. And it in that capacity, it could be applied to systems from 10, 20 years ago because of that broad scope of what the term is applied to, which is just this thing that can perform operation, that you can make requests of and it can perform operations on your behalf. But again, the word means different things to different people. And some people reserve it to be more this AI reasoning capable, tool accessing, self-orchestrating, thing. Mm-hmm. But it really depends who you ask. And I've tried to, for a while, it bothered me that everything was getting slapped with this moniker. And then I was just like, whatever. Fads come and go. The terminology will come and go. But the concepts are here to stay.
That's true. There's so many concepts. Once a specific subcategory of this starts getting more productized or more well understood, I'm sure a more specific name will emerge for exactly that thing.
Yeah. And in 10 years, we'll probably be reappropriating the term to mean something else. Yeah. And people will laugh at how we were applying it today. And we'll see. This stuff is so fluid and moving so fast.
Yeah.
It's one of the hard things about having been around and thinking about AI for the last couple of years is things that I thought I knew yesterday are different today, and things I think I know today are different tomorrow.
Mm-hmm.
It's just progresses so fast, and it's trying to get into the mindset of building things based on capabilities that don't currently exist, but at the speed at which they're progressing, they will in 3 months.
Right. So we talked about possible very big changes in the way we build user interfaces with applications or augment them. We talked about making automated actor programs, agents, which we've had that style of programming, for a while. Let me just have this job over here that just does something automatically and listens for things. And now we have a way to possibly interact with it, or just have it sitting in the background looking for stuff and doing things. There's also some rumbling. It seems really new, calling into question the way we integrate with other systems. And you got the MCP libraries. And is that just kind of research, or what do you think is happening there?
One of the key things that makes these systems viable for doing anything other than question and answer is their ability to interact with things other than the data that's stored inside the model, right? So these AI models are created by starting with some very, very large source of knowledge, like the entirety of the internet, and training a neural network based on all that data. And then interacting with the model is you basically issue a query against the model and you get back a response. And from that, in that world, the only thing that it knows is the data on which it was trained. It's also not able to do anything other than surface that information back to you in some form. But if I say, what is the current time? It doesn't know that. Certainly the current time wasn't baked into the model when it was trained 6 months ago. Right. And if it was, it doesn't know this minute from the next minute. So for it to be able to integrate things that have happened since the model was trained, things based on the current environment, things based on my systems, things based on me, things based on whatever, it needs the ability to go beyond what the model is itself capable of. And that's achieved via tools. And those tools might do a web search. Those tools might access the current time. Those tools might perform a calculation. Those tools might integrate with my business system. Those tools might submit a form to my HR department or an expense report, right? Those tools can do, if it was a developer tool, it might grab a dump, a diagnostic information from my process. Whatever it is, you supply these tools, and the models are then trained not just on information on the internet, but they're trained on recognizing requests that might benefit from calling out to descriptions of one of these tools. And then when you issue a request, rather than when I say, what is the current time, the model won't come back with 3:42. The model might come back with, based on the fact that when you ask for the current time, you also supplied me with the name and description of a tool that's able to get the current time. Please invoke get current time, and then make another request back to me once you know it. And then I'll give you the response, right? And so providing those tools and those capabilities is what really makes these AI systems shine, because that's what allows them to break out of just the data, just question and answer of the data they have.
Yeah.
And so providing those tools becomes really important. And how do we provide those tools in a systematic way and in a reusable way? And you mentioned MCP, or Model Context Protocol. That's something that Anthropic created back in November, I guess. It's only 4 or 5 months ago. And
I think they open sourced it then, yeah.
And it's taken off like wildfire in the last month or two. Everyone's kind of jumping on the bandwagon because it's effectively an open standard for how you describe and distribute these tools, such that someone over here can create a tool and someone over here can just easily consume it as part of their AI system. And this then allows lots and lots and lots of these tools to be built up, and anyone who then needs a particular set of capabilities can just plug them into their AI system. And this then allows them to it's just reusable libraries all over again, right? It's just a particular kind of it. We don't want developers having to re-implement quicksort. We don't want developers having to re-implement search, right? You build libraries as part of your platform that provides those capabilities. So they don't have to do that. The AI tools are the same thing. I don't want every developer having to relearn how to do Google search or Bing search. You provide a tool that's able to do Google search or Bing search, and then it's easily plugged into the AI. And like that, the AI has the ability to access all these capabilities.
So when I think about tools to register, whether it be just registering it directly or using semantic kernel. I can make an arbitrary C# class that knows how to call into some aspect of my system to get things back in real time. But for the longest time, integration kind of has been dominated either by asynchronous queues or web services. When we think about, oh, how do I make system A talk to system B? Those are kind of the technologies or techniques that have come up. This seems like now this is a new way to do system integration, and a lot of context protocol. Keyword that stands out is protocol, which, I mean, email and web services, everything's based on the protocol, and then all the different platforms have their implementation. Is this, I mean, this seems big to me. What's your thought?
Conceptually, I mean, you threw out a few buzzwords, right? Conceptually, it's not new. Conceptually,
right.
It's there's some protocol, there's some agreed upon way for A to talk to B.
Yeah.
And in software in process, that might be a calling convention, right? That's a simple protocol for how does a caller call a callee? How does a method call another method, right? That's a protocol. When you're talking about web services or you're talking about REST or whatever, there's a protocol that dictates, hey, if A wants to call B, here's how it does it. And we've had a litany of these over the years. And so from that perspective, it's nothing new. It's just for every particular domain, you end up with intricacies of that domain that often warrants its own special thing. And so MCP is specifically focused on how do I enable AI systems to call functions. And that means that you need to surface certain information about your tools. So there's an operation in the model context protocol that is just list tools, and it's really just a JSON RPC payload that says list tools, or something like that. Tools/list, I think is the method name. And you get back a JSON object containing an array of descriptions of all the tools. And the description is basically just a name. What is this thing? How do I refer to it in the future? A description that is a human readable description, which is important because these AI systems are trained based on human data, right? So the descriptions that are useful for us are also useful for these AI systems because they are basically people emulators.
Yeah.
And then a schema that describes the arguments to the function, the name of every argument, whether it's required or not, and a description of each. Again, a human readable description that describes each of these things. And then that information can just be handed when I make a request to the AI model. One or all of those descriptions can be packaged up as part of my request. And then the AI model can say, okay, well, as part of your request, I see you're giving me a tool named foobar that takes an argument blah. Please invoke foobar with zoo and give me the result. And then I'll give you the answer you were looking for. And it may not be I'll give you the answer you're looking for. It may be that foobar actually performs some side effecting operation and so changes the environment around me. And that's all model context protocol is. It's a list of these things that can be performed. List tools, list prompts, list resources, call tool, get prompt, read resource. And it's things that are specific to this domain, like prompts. So prompts are just text that you provide as to the LLM to allow it to then complete with an answer. And it's the model context protocol recognizes that in this AI domain, it's not just about describing tools in a way that's useful for these AI systems. It's also about, well, maybe there's some knowledge that I want to imbue into a prompt. So I'm just going to give you a list of prompts that can then be sent to the LLM. For example, in a development capacity, if I wanted to build an expert debugger MCP server, I might have some tools that allow you to do things like get a dump, but I might have a prompt that says, as an expert debugger, here are the steps that I would take to diagnose an issue. First, I would grab a memory dump. Second, I would run the following commands. And then the MCP client can not only have access to those tools, but it can see, oh, okay, there's a prompt called expert debugging. And so it can effectively download that prompt and then submit that prompt along with all the tools that I got to the LLM to teach the LLM how to become an expert debugger.
Yeah. Nice. Well, as we kind of come to the end here, there's so many aspects of generative AI and what .NET is doing in Azure. What parts of it do you find yourself kind of digging into these days? There's so much that you could spend time, personally doing, but what seems to be drawing you in?
I mean, so I live at the bottom of the stack, effectively. As you mentioned, I work on the .NET Runtime and the core libraries and sort of the things that everyone else builds on top of. And so at that layer, the things that I care about are the support for AI that enables the ecosystem above the core libraries and runtime to flourish. And for us in core libraries, that means sort of the fundamental support that developers need to be successful, but more importantly, the exchange types, the abstractions, the thing that everyone agrees on is the way to talk about a certain concept. System IO stream is the shared representation for how you read and write bytes. And it's important that System IO stream be in the core libraries so that anyone else building libraries and applications around the .NET ecosystem can just work in terms of stream. You might provide a Jeffrey stream. I might provide a Stephen stream, a network stream, a buffered stream, a file stream, but everyone can interact with these things in terms of the abstraction stream. I can write a function that writes to an arbitrary stream. I can write a function that reads from an arbitrary stream, and different implementations that can be plugged in. From an AI perspective, it's no different. So we have been working hard on Microsoft.extensions.ai, which took another library to go along with Microsoft Extensions dependency injection, Microsoft Extensions logging, Microsoft Extensions hosting. Microsoft Extensions AI provides a set of these primitives, a set of these exchange types to represent things like interacting with an LLM via an iChat client, or interacting with an embedding generator for doing retrieval augmented generation and creating embedding vectors, or converting speech to text, or whatever, these abstractions that everyone can agree on and libraries in the ecosystem can then use without having to understand exactly who they're talking to. So for example, the MCP library, right? Anthropic now has an official C# SDK that we're helping with. And it uses Microsoft Extensions AI abstractions as core primitives. So you can very easily just say, I want to make calls out to an iChat client, and I'm going to give it tools that I get directly from an MCP server that are the AI functions, which is the core abstraction for an AI function for Microsoft Extensions AI. So I can just take anything that I get from an MCP server and hand it directly off to the tools collection that's passed into an iChat client. And then if I have an iChat client for OpenAI or for Anthropic or for Mistral or for Onnx Runtime or for Olama or whatever, I can write libraries in terms of just these primitives, and then any of these things can be plugged in. And so from my perspective, that's where I'm spending most of my time, is on that layer, because it's the enabler that allows everyone else to do what they need to do. So, and you briefly alluded to Semantic Kernel earlier. Semantic Kernel is a set of libraries that's been around for, I guess, 2 years now. And Microsoft Extensions AI was sort of born out of Semantic Kernel. We basically took the lower layer of Semantic Kernel and refactored it into Microsoft Extensions AI. And now Semantic Kernel is replatting on top of Microsoft Extensions AI. So in the future, the primitives are all Microsoft Extensions AI, and then Semantic Kernel provides the additional higher level libraries like anyone can, and provides a set of agents related libraries and business processes libraries and prompt related libraries and so on. And then there's a set of evaluation libraries from Microsoft Extensions AI evaluations, and there's the MCP library, and they all just layer on top of this core set of exchange types. And then if you go on to NuGet and look at search around for AI-related functionality, you'll find like 50 or 60 packages already that depend on Microsoft Extensions AI abstractions, some of which are consumers of these exchange types, and some of which are implementers. So you can find, implementations that talk to the AWS service for an iChat client implementation for AWS, or an iChat client implementation for Anthropic or whatever. And by providing that lower layer, it enables this ecosystem such that everyone can talk to each other without having to know the specifics of each other.
Yeah. And for any listeners out there who haven't even looked at this, it is impressive how with just 10 lines of code, it's just a quick local next finish install of Olama and a tiny, one of the small models, 10 lines of C#, and now I have actual .NET that's interacting with a large language model. Not ChatGPT, but my code is very impressive.
It's a lot of fun. And the things you can do with this, Olama supports tool calling, at least with many of the models that you would plug in with Olama. And with the MCP library exposing all of these MCP tools as AI functions, and with Olama Sharp providing an iChat client that accepts AI functions, you can, in one additional line of code, basically create your MCP client for that server over there. And in one more line of code, get all of its tools and route them into the iChat client. And so in 2 additional lines, you can connect any MCP server and make its tools available to Olama.
With all these we talked about, I can just imagine so many software teams that have reports or reporting databases, just layering on MCP for describing the different fact tables and just letting it be an English reporting query, show me this over this, group by the. I mean, so many teams have that kind of use case where that doesn't seem like a big lift with this set of technologies.
It's already here.
Yeah. Fantastic. Well, Stephen, thanks so much for coming on the Azure and DevOps podcast and catching us up with AI in the .NET ecosystem. Thanks so much.
Thanks for having me. This is fun.
Oh, my pleasure. And until next time, keep shipping.
You've been listening to the Azure DevOps Podcast, a show for developers and DevOps professionals shipping software using Microsoft technologies. Go to www.azuredevops.show for show notes and other episodes. On behalf of your host, Jeffrey Palermo, and our sponsors, thanks for listening, and may God bless you.